Good morning to all of you. Okay, Totoshi, thank you. Okay, Rohit Sheth, we'll wait for another 2 minutes. 11 o'clock we'll start the class. Let others join the class because 2 minutes are there still. Thank you for your message. Okay, let us start the class, and we are discussing A to D converter, D to A converters chapter, and we have discussed in the last class a single ramp A to D converter, counter type A to D converter we have discussed in the last class. Now we'll try to discuss a successive approximation A to D converter. So let us revise what all we have discussed in the last class, because revision will help you to understand better. And please keep your eye on the screen and try to understand before I tell the next step, so you people try to recall it in your mind so that it will become easy for you to remember. Now we have discussed in the last class a single ramp ADC. Reset is applied to the ramp, and now counter have made 0, counter is 0 0 0. Next step, a comparator input we are giving 0 volts, and because of that output of the comparator will become high. When this becomes high, clock will reach the counter and counter starts counting. When counter starts counting, and next what will happen? Now the ramp voltage is also increasing. Because of this, the voltage at inverting terminal becomes greater than 4 volts. Output of op amp becomes low. AND gate disables. Counter stops counting. Control logic will send a latch signal to the latch and reset signal to the counter. So this is a single ramp A to D converter we have discussed. And counter type A to D converter also we have discussed. Their binary counter is reset to 0, and output of a DAC is also 0. Comparator compares a VI and DAC output, and this is a reset given to the counter. Then 0 0, output is 0. Therefore output of the comparator will become high, and because of this the clock will reach the counter and counter starts counting. And because of this counter increasing, DAC output voltage will also increases. So this reaches greater than 4 volts. So that time output of the comparator becomes low. So because of this low, the clock will not reach the counter. Therefore AND gate is disabled and it will stop, and automatically control logic will send a latch to the counter, and reset will be sent from the control logic to the counter. So these things we have discussed in the previous classes. Now today we are going to discuss a flash A to D converter, successive approximation A to D converter. Then we will go to the flash, then we will go to the dual slope A to D converter. So try to understand. Hope all of you know the searching. How do we search a given number in an array? You have written the program also. Say I want to search X number in an array. I will take X and I will compare the first element of an array, then I will compare the second element, then I will compare the third element. Like that I will go. If array length is very high, then the time taken will also change. How much time it takes to search a number, what number I am searching. If it is available in the first element of the array, it takes very less time. If I am taking say 1000, and if a 1000th position that number is there I am searching, means automatically it will take more time. And other than this linear search, hope you people might have come across some other search. Anybody can type any other searching other than linear search? Okay, let me tell you. Other logic is a binary search. So if the numbers are sorted, if it is in the ascending, descending, automatically I can go for a binary search, which will take less time to search a given number compared to a linear search. And 8 numbers are there. First I will start at the middle. So I will start with the middle, and then what I will do, based on my comparison result, whether my number is less or more compared to that a fourth position element, either I will go to the above or below. Like that, every time I will divide by 2, divide by 2, divide by 2, automatically the time taken will become less. For example, if my number is less, I will go to the above. This much I will never search at all. So like that, every time 50% I will leave. So this will take less time to do that. And consider it is a sorted and searching. See what I do, I go to the middle. Middle means 8th position. 8th position, try to understand this. I will go to the 1 0 0 0 0 if 16 are there. Then based on the result, either I go up or I may go down. So this I can have like a tree structure. For example, 8th position I am going first. Then I may go based on the result, whether is it greater than or less than, I will go to the 12, or I can go to the 4. Again from 4 I can go to the either 6 or 2. Again from 12, if I am that side, I may switch out to the 10 or 14. So take a 1 minute, copy down from this. Try to recall a counter type ADC. In the counter type ADC, a counter we have used, and D to A converter. I used to get a voltage, we used to compare this, you please try to recall. Now, only the difference is what? Instead of counter, I am going to use a successive approximation register. That's all. Remaining operation will be as it is. What the SAR does, in case of counter, we know it will start from all 0, then all 0 1, then 1 0, 1 1, 1 0 0, 1 0 1, like that it will start. And last is all 1. This is a counter. But SAR is, it will start with a middle. For example, 1 all 0. That will become a middle of anything. You can take 16, then 1 0 0. If you take 8, 1 0 0 will become a 4. A half, it will start from that position. That is a SAR. And let us go to the block diagram of a successive approximation A to D converter. Remember, don't take it as a small circuit, and it is easy to understand. Actually, tell you frank, one of our faculty has done, I think, PhD on this A to D converters, and somebody has done MTech project on A to D converter. Somebody got a patent on A to D converter. So please try to understand, these are very important. So copy it on this, we'll have a discussion after 1 minute. Most of them they are completed. Let me now I take 5 minutes so that I can binary searching is very fast compared to the linear search, because n bit conversion is only n clock pairs it will take. Idea is what we are adjusting the tag input such that this become a plus or minus half LSB of an analog input. Actually, in this whole diagram, SAR, successive approximation, is a heart of this complete circuit. Let's take 1 or 2 lines from this. We will continue the discussion. Anyway, let us go to the next. Now, SOC receives then SAR sets. It is nothing but a start of a conversion. So I am giving start of a conversion, and SAR will set a MSB 1 0 0. How many zeros, sir? It depends on how many total bits are there. In the counter also you have 3 bit, 4 bit. So first one will be 1, remaining all will be 0 based on number of bits. And then I think you can take just 1 line from this. I will wait for 40 seconds. Let us go to the next. Now, DAC generates equivalent voltage, whatever the SAR giving. We'll get a V2. and this V2 is given to the op-amp inverting terminal. Now if this V2 is less, comparator output becomes high. When comparator output becomes high, then what the SAR does, it will keep the MSB as it is and it will set the next. It will become, instead of 100, now it will become a 110. 110 is given to the DAC and DAC will generate again some voltage. This is a first case. Or second case, what may happen, this voltage itself become more compared to this, that time this will become a low. That time what will happen? So that time when this V2 is given, if V2 itself is more, sir, compared to V1, this will become low. So when this become low, the SAR makes the MSB 0 and it will set the next and you will get a 0, 1, 0. So please remember, at the second stage, a case, there are two cases. If it is a high, earlier 100 was there, it will become 110. If this becomes a low, then it will become 010. Means I am skipping the half and either I am going to the above half or below half, depending upon the op-amp output, whether it is a high or low. So try to understand and try to read this. Whatever I explained, the same thing is given in this slide. Copy down, you have 1 minute time. If a comparator output is less than high, then SAR keeps MSB and next LSB is set to 110, and like that this process is repeated for the next 2 more clock pulses, so that another 2 more bits will be decided. So if MSB is decided in the beginning, next second bit, third bit will be decided. As soon as the last bit is tried, SAR forces end of conversion signal to enable the latch. Okay, this is DAC generates equivalent rule. This is a concept we have discussed already. I think now we'll go to the one example. What you are supposed to do, you are supposed to write whether it is 0 or 1. Can you type the first one? See, Vi is almost equal to what I am giving V1. It is almost, its digital equivalent is a 10110010. Now V2 beginning, when I start, it will be 1 all or 0. Now its equivalent voltage is coming at here and voltage V1 is equivalent digital is this. Whether the output of a comparator is high or low, you are supposed to say whether it is a 0 or 1. Whether this is more or this is more voltage, you can understand by saying the digital equivalent. So based on this, you can say output of the comparator is high or low. First one you can say, similarly all you can write down. All of the students are writing 1, yeah, I agree. Because this number bada hai. That's why this should be high. Similarly, you continue and write down till the last. Someone can write all zeros and ones, totally 1, 2, 3, 4, 5, 6, 7 bits. Take a minute and do it. I'll wait for your answer. Most of the students, they are typing almost same answer, 10110. Yeah, always 10110. And some students, they are typing bit by bit. Rajat, very good. Pavan Gutti and Abhinandan Appannavar. Appu K 101100 Appu. And Aditi 101110. Okay, correct. 1100. Okay, most of them, they are getting the same answer. Let me show my answer to you people. You can compare, is it same or not? 101100. Anyway, 101100 is correct. And now let me go to the next. Before we go to the flash ADC, let me conduct a quiz now. And hope all of you are having a calculator. And 5 minutes you can take. Again, I am reminding you, whichever questions you know, first attempt those. If you feel some question is difficult, leave it. At the end you can do it, because time will be 5 minutes. Okay, and let me share the link. Today we'll conclude the class now. Take care and we'll discuss next class 2 A to D converter, flash ADC, and one more is dual slope A to D converter. These two will discuss in the next class. I'll be here for another 5 to 10 minutes. If anybody want to talk to me, I'll be here. Okay, take care, bye, see you in the next class. Have a good day, be safe. Thank you. I'll be here for another few minutes.